and welcome. I'm Susan Bridges, the president of the Brewster Ponds Coalition. And for those of you that are meeting us for the first time, we are an environmental nonprofit organization now in our 11th year. Our mission is to protect and improve the health of Brewster's Ponds through science, education, and advocacy. I think I have a... There we go. For the past few years, the focus of our educational programs has been on impairment to water resources from wastewater, specifically discharges from septic systems. The reason is that wastewater from septic systems is recognized by the state of Massachusetts as accounting for 80 to 85% of the man-made impairment to the aquifer, ponds, and the estuaries on Cape Cod. Septic systems do a really good job of removing bacteria. However, they do not address nitrogen and phosphorus, the nutrients that in excess are harmful to our ponds and can lead to toxic cyanobacteria blooms. They also do not address chemicals of emerging concern, such as pharmaceuticals and PFAs, which are man-made toxic chemicals found in water-resistant fabrics, cookware, personal care products, and food. So today, we are lucky enough to have two speakers who will be talking to us about chemicals of emerging concern. Tom Cambareri, who is a water resource specialist and hydrologist with Sole Source Consulting, and Tom Barr, the Deputy Director of Public Works for the town of Chatham. Tom, our first speaker, Cambareri, our first speaker, is a practicing hydrogeologist and proprietor of Sole Source Consulting, LLC. Tom works with interested parties on water resource management issues, including water supply, wastewater, coastal and fresh water quality, and offers services in hydrogeological contamination assessments, remediation solutions, wastewater management, affluent disposal, and groundwater modeling. Tom also, in the past, was the Director of Water Resources at Cape Cod Commission for 30 years. And there, Tom focused on the protection and restoration of water quality and water resource management. His highlights, some of the highlights included technical review of comprehensive wastewater plans, the 1978 and 2015 update of the Cape Cod 208 Regional Wastewater Management Plan, the long-term cleanup at the Joint Base Cape Cod, water supply assessments with the Outer Cape Towns, and National Seashore, the Cape Cod Ponds and Lake Stewardship Project, otherwise known as POWS, the Mass Estuary Project, the Regional Groundwater Modeling Projects with U.S. Geological Survey, and management of groundwater cleanup at the county's Fire Training Academy. Tom presently serves a number of municipal and private clients on water resource issues, including groundwater modeling of PFA contamination, wastewater disposal and surface water impacts from water withdrawals, peer review of golf course monitoring programs, independent review of PFA assessments and remedial actions, and water quality and level monitoring systems. So welcome, Tom, and thank you for coming.
Okay.
Here's our agenda.
Here's your agenda.
It's pretty simple.
Oh, thank you.
Did I go backwards?
No, you're perfect. Thank you for the introduction. That's about half my talk. So, no, it's a pleasure to be here with you this morning. And hope you all hear me. I don't know whether that, yeah, it does work, okay. And let me just check my pointer ability here. There I go. Everybody see the pointer? Thank you. Yeah, and I just want to see this goes. Okay, good. And yeah, Susan said, so I kind of, my talk today is going to be kind of focusing on this issue of compounds of emerging concern. I know your pond group, and you've done a lot of great work on the ponds and wastewater up here in Brewster. But today we're going to take that and we're going to focus on this and actually maybe talk a little bit about the pond issue of PFAS that we're dealing with in Hyannis. So, as I go through these things, and I've been doing this stuff in groundwater work on Cape Cod for 30 years, so it's almost like I'm telling you a scientific story. I'm telling you the story of my life. And so I retired in 2019, and I'm still, kind of fully engaged, a little bit too much with this work. So I am happy when I get a chance to come out and see folks like you that are working and doing groundwork and are fully engaged. So, speaking of my work and my history, I just want to start off my talk with my first moments in Brewster was when I was 3 years old, and we stayed at the Bay Breeze cottages and in Brewster. I think they're still there. I don't know. At 6A, and there I am with my sisters at the Brewster Grist Mill. We were doing a research project on herring runs back in that day. Anyway, so I'm whether you can tell from my voice or not, I'm a New Yorker, from Westchester, and I did land here in 1978, fully engaged, after college. So I've been on the Cape since 1978. So all my talks begin with the map of the Cape Cod sole source aquifer. So here we have Cape Cod, and those blue lines are topographic contours of the surface of the water table. And back in 1981, we were looking at the USGS reports that for the first time documented that. So it was a big leg up to help us understand how this aquifer works. And they had this, this is the West Cape model, this is the East Cape model, this is this. So we said, we need some names for these lenses. So we came up with these names, and we proposed it to the USGS. And so now we have, the Sagamore lens, which means the chief lens, and then the Monomoy lens, all named for the Indian tribes that were here, and the Nauset, Chequesset, Pamet, and then the old Pilgrim lens to commemorate the 1620 landing by the Pilgrims. And so we look at this sole source aquifer, and it's our sole source of water. It comes from rainfall. It doesn't come from any underground rivers. What falls underground goes into the aquifer, replenishes it. And those contours are very useful to us because we can tell how groundwater flows. And it flows basically perpendicular to those blue lines. And we can help manage all our water resources because everything's connected, the water supply wells, the ponds, the estuaries, the streams, and we're all part of this water resource. And when we look at the cross-section of this aquifer, we see the top of the water table, which moves with precipitation, bound on the bottom by bedrock, and with a zone of transition that we used to pump the wells off and measure where the fresh water was, Oh, there's salt water. Okay, now we know where the zone of transition is. And that aquifer is, we like to say generally it's 350 feet thick, and it's a huge, vast reservoir of underground water in the sand. But you know what? It really isn't. When that diagram is totally wrong. It has this huge vertical exaggeration. So if I drew that aquifer to scale on that, it would be probably about like that. So it's really a thin film of fresh water that we survive on, and we all take advantage of here on Cape Cod. And I talked about the fluctuation, and we have part of my life story is when I landed here in 1979. I started measuring the wells for the county back in. So I would spend 3 days a month, and I would measure 60 monitoring wells from Falmouth all the way up to Provincetown. And this was before GPS or anything like that. And I only had USGS maps to get me around. So that was, you could see me in the car with all these USGS maps getting around. But I learned all the back roads. I learned all the ponds and everything. And this is a well that is in front of Nickerson State Park that I used to measure. And now it has a real-time device measurement. And so just, this is today's readings. And so this shows in green the normal fluctuation through the year and the mean. And then these red dots show where we are relative to the mean and all that. And so look where we are. We're kind of low. We're in less than the 10 to 25% percentile. So you'll be hearing more about this drought that we've been in. We've been hoping for more rain. We got some rain this week, so I was curious to see if it came back or not. But we're right about here, so we're really on the low end of this thing. These measurements are from 1976, a little bit before I started moving across. And my measurements are probably in this zone here. I did all those measurements. Think of that. So here's our sand and gravel matrix left by the glacier. Very porous material, and when you go deep enough, when the water accumulates from the rainfall, it turns into our aquifer. And so we have the wells go through this zone of aeration where there's no significant water, and then you get to the water table, and then all the sand grains are saturated, and that's basically a situation. That's how we get our water from these wells. So not by a bucket anymore. Now we have gravel pack wells, and so there's about over 150 gravel pack wells across the Cape, and those are you can see those as the black dots, and you can see the Brewster areas here. And Tom's Wells we'll be talking about, Chatham over here. And what we came up with in early 80s was, well, we know how the water flows from the water table map. We know where the wells are. How do we protect it? How do we better protect it? And we came up with this a methodology to recognize the watersheds to the wells, where the wells get their water from. And so those are the areas of pink. And those became, embraced, the methodology was embraced by the state, embraced by EPA, and so now we have these zone 2s you've heard about, right? So those are the zone 2s across the Cape. And our aquifer produces about 10 million gallons per day in the off season, 25 million gallons a day in the summer season. And when I was working at the commission, we accumulated a lot of this data. This chart goes to 2015 from 92, and here's the 10 million gallon per day average, annual average. So when we look at this, I'm not sure what's happened after COVID, after 2015, but our pumping regionally is fairly stable when you put it all together. So some towns are have more development, but for the most part, it's been relatively stable. And the pumping from the aquifer is about, I said we only get our water from rainfall, so it falls all over the Cape. And when we pump out of the aquifer, the amount we're pumping out is probably about less than 10% of the total water budget for the aquifer. So how is our water quality on the aquifer? Well, we got to go back. When was it first tested? And so I always go to this, the quote from William Bradford in 1620. And he says, about 10 o'clock we came into the deep valley full of brush and wood and long grass, through which we found little paths or tracks. And there we saw a deer and found springs of fresh water, of which we were heartily glad, and sat down and drank our first New England water. So that's our first report, water quality. It was really good in 1620. And if you've ever been to Pilgrim Spring up there, it's just like a place I visit. I go and I've actually measured and done some investigations of it as well. So what's happened in the interim here? Well, we've got groundwater contaminants, and I'm not saying it all started in the 1950s, but this is kind of a progression of what we've learned over that period of time, and that we've dealt with the nitrate, sodium from road salt, and phosphorus, that we realized for the impacts on ponds. And that was our big issue when I first landed on the Cape in 1978, was how do we deal with this nitrogen problem on the wells. We weren't thinking so much about the ponds or anything. We wanted to protect the wells. So that's kind of what we were focused on with the zones of contribution and regulations and zoning and performance standards. And then we had all these gasoline leaks. The Provincetown spill. Does anybody remember the Provincetown spill in 1977? Well, at the province, there was a gas station right up there in 1977. The gas tank leaked. Hit the groundwater, went into the wells, shut down the Provincetown water supply in 1977. It was a huge issue. And it gave us thoughts to like, well, if that happened there, where else can it happen? And the story of what they had to do to find water in Provincetown was pretty astounding, but very a lot of people came together there, and I think Mark Forrest, that he was an assistant town manager or something like that up there at that time. So I think that's how he got his he got introduced to Jerry Stubbs and that at that time. So then we had heating oil. Well, everybody's got heating gas tanks. We got to take care of the home heating oils and gas tanks and tanker rollovers. And then, as we're getting into that, solvents, and Love Canal happens. We've got TCE, tetrachloroethylene, and we've got dioxane, and the EDB, which is part of fuel and oxygen. Pesticides, transformer oils, and MTBEs. Everybody remember MTBE? It used to be in all the gasoline at a time. When you went up to your gas tank, your filling stations, and contains MTBE. Well, they found out that was a pretty big contaminant, and they were finding that all everywhere. Besides the gasoline, it was more recalcitrant. It stayed around, so they got rid of it, and that's why we have ethanol in our water supply, in our drinking, our gasoline now. Well, we do find a little bit of that stuff in our drinking water. As well. And then, so as we're dealing with this, all of a sudden, we can say, well, what about explosives and that? And I have a colleague of mine who's in the audience today who was managed to clean up at the military base, and his work was to clean up the explosive residue that got into the aquifer, and it was unbelievable. This RDX, Royal Dutch Explosive, and perchlorate. And perchlorate comes up a little bit later in my talk, because perchlorate is part of fireworks and is part of all these marine flares. And of all you boaters, you've got marine flares, and what do you do with them? Every 3 years, I hope, you got to get new ones. Cost like $40. And where do? You bring them to the fire department, and what happens there will be part of my story. And then we've got pharmaceuticals, cleaning compounds, and food components. And we're finding caffeine in the water supply now. We're part of the wastewater that goes into the water supply, and that's and different antidepressants and things like that in the water supply. It's minute levels, but you can find it. Oh, and diet sugar, sucralose, is another compound that doesn't dissipate. You find that in the water supplies too. Private wells, a lot of the private wells. Not so much in the big water supply wells. And then we're getting finally down to the PFAS, the polyperfluoroalkyl substances, and then kind of the one that's been around for a while but's come up for more topics lately has been microplastics. So I'm going to talk about the PFAS work and a case study. So first, I want to show you how these contaminants move in the aquifer, okay? So what we did is we put together this sand tank model, and the sand tank is going to represent the aquifer in that cross section, and we're going to put some dye on the top of it. Okay. And now, how do I get that to work? Okay, so here's the dye going onto the top of the aquifer, and there it goes. And so you can see it doesn't all conjoin, it moves in discrete pathways. And so each one of those things could be a septic system, it could be an oil tank, it could be a PFAS site, and it moves through the pore spaces within the aquifer, and it's moving because the water is moving through the aquifer. It's a dynamic water body. You know, the aquifer is moving from the high areas, like in Brewster, at Long Pond, all the way out to the sea. So that could be Cape Cod Bay, or it could be Long Pond. But that's how it works. And then once the source stops, you're seeing the dye is kind of dissipating. Things are starting to clean up over there, and the aquifer is moving through. And we're really lucky in this case because he's representing a contaminant that can move through. It's not tenuous, it's not sticking to the soils like PFAS. PFAS sticks to the soils, and the last report is that contaminated areas are going to continue to contaminate for centuries. So so we look at those how those plumes work in 3D, and we've got this other great experiment here at Mass Military Reservation, and these are the various different plumes of contamination that have been mapped at the expense of millions of dollars to map how the contamination has moved through the aquifer, and you see also you can see the blue lines of the water table, and you see how these plumes are flowing perpendicular to the water table, into ponds, into the estuaries, in some cases else. So now for my Hyannis case study. For those with some general reference, here's the airport rotary, and you're coming over to Brewster down Willow Street and getting in the traffic jam. You're coming down here into 28, and this is 28 heading over into Falmouth and 132. And Independence Park Drive is up this way. So we have a couple of sites where PFAS activities took place. One is the Barnstable County Fire Training Academy, and I worked on that from 1986 to 2018 before I retired. And so this is going to be the story of my life, I'll tell you. It's still going on. And then this is the airport, and the airport had several areas where it practiced work with PFAS compounds. I'll tell you a little bit about that. And these are public supply wells in black. These couple supply wells here, the Mary Dunn wells, the Mar wells that have been around since 1908. And then this is the wastewater treatment plant here in Hyannis. And there you go. Here's our water table contours again. This is from a groundwater model that I've been using. I'm working for the Silent Spring Institute, and I'm doing a model on PFAS contamination looking back 50 years, because people have been using PFAS for 50 years. We didn't know it. Well, we knew what they were doing, but we didn't know PFAS was part of it. So this sets the stage for the case study. And here's the groundwater flow, general groundwater flow directions from all these different sites and sources using the water table map. And use particle tracking. This is where you can use the model, and you can say, well, if I want to know how groundwater is flowing, I'll put some particles in this computer model and see where they flow. And the airport's groundwater flow is heading kind of right towards this Mill Creek Marsh and the Mar wells. And this fire training academy is it's only like 1,500 feet from the academy to these wells. And so it's going right into these wells. But as you'll hear, these wells have had quite a history of contamination. So they've been on and off over periods of different times. So when they've been off, this contamination is no longer sucked up by the wells, but it keeps continuing further down, kind of joins up with these plumes here. So this is the Barnstable County Fire Training Academy, and in 1970, and the county commissioners used to display this quite proudly in the office back in the day, because it's where everybody practiced the fire training here, and you can see the kind of the fire training pits here that they trained in, a burn building. This is Flint Rock Pond here, and the diagram that you saw showed groundwater flowing in this direction, further away from the Flint Rock Pond. So quite a lot of activity. It started up in 1950s, and it basically shut down in 2019, primarily due to the PFAS situation. So I call this my contaminant showcase for the Fire Training Academy. And so here's the Fire Training Academy here. And these are the public supply wells, Mary Dunn 1, 2, and 3. And when I first started with the site, it was 1986. So we had this petroleum plume that coursed through and was hitting the wells. The wells kind of were shut down. And I worked with a bunch of people trying to clean that up. And so we did. We got that fairly clean. There's still residual soil in the soil there. But then, just about the time we were cleaning that up, we got a knock on the door, and there was a chloroform plume that came from Cape Cod potato chips. And Cape Cod potato chips, and this was a big lesson to me at the time. They used chloroform in their laboratory. I forgot what they were doing. They were checking out the fat content. They weren't using chloroform in the beer. The beer is still good. Okay, okay. Don't stop drinking it. But they figured out that they lost about 2 gallons in their operations of putting a little chloroform in their sample and tossing it into the drain and going into the septic system. And so that chloroform plume, what happened to it? Oops. There's the chloroform plume. So that had to be cleaned up as well. And then I talked to you a little bit about MTBE. The firefighters were still out there, and they were like getting rid of cars, fires, and they'd get old junk cars, and probably somebody had a ruptured tank there. So that MTBE plume had to be cleaned up. And then I talked to you about the marine flares and all that. So just as I'm thinking I'm done with this site, and I cleaned it all up in 2007. I'm working a little bit with Greg on his work over there at the MMR, and they're talking about perchlorate that they found. And, it's associated with fireworks and marine flares. Oh, that's interesting. All of a sudden, I'm looking around the Fire Training Academy, and there's like a cache of marine flares, like that and this. So it turns out they were using it to help start the fires out there. So that ended up in a giant plume of perchlorate contamination. So we cleaned that up, and there's a residual contamination around by about 2010. And then that was about where we were until the PFAS situation hit the fan. And so PFAS compounds, I'm not going to go into a lot of detail, but you probably read about it. PFAS is used in a lot of different household items and things that we use every day, right down to Glide, dental floss, and there's been so much of it around that they started producing it kind of in the 40s, and then in the 50s they really started manufacturing it and putting it into a variety of different products. And so we were all aware of the Stainmaster, carpets and Gore-Tex and things like that. So there's this pervasive, everywhere. So such to the point that just about all of us has PFAS in our blood presently. If you go and get a test, you'll find PFAS in your blood. And that's kind of globally, a global situation. The rates have been coming down since 2009, which is a good thing. So this is an old home movie from the fire training area. I'm just going to let you watch it. Yeah, this is 1966. So this is what they used to do at the Fire Training Academy. And this is a, that's a phone booth.
Oh,
Not a phone booth, phone booth. Okay, so they did a lot of that stuff for this. So what they're using is aqueous film forming foam, and it's highly concentrated in PFAS compounds. And it was in use, from the probably late 50s, up until, at this site, up until 2015. Same as the airport. So the airport was doing training with this as well. Nobody really knew about it, about PFAS in this product, AFFF. But it's a highly concentrated in foam. And let's go back and look at it just one more time. So what they did at the Fire Training Academy is they had a tank of petroleum, diesel fuel, and they would fill up these concrete pits with oil, and they'd set it on fire, and then they would practice putting it out with water and foam and that. And you need to be able to respond. This AFFF was a device by 3M for the Navy, having to deal with issues of the planes landing on aircraft carriers and that kind of thing. So it's very helpful, and it's become, it became integrated with all the training of firefighters. If a tanker rolled over, or if a car rolled over, then you would spray it with this foam that would suppress the air so that it wouldn't catch fire. And they still use it in airports now. I forget where that poor plane came down and rolled over, and you see the pictures, and they're using foam still because it's made with human life. You got to save human life, and they've changed these products a lot too. So what are the regulatory limits for this product? It's changed over time. When we first detected it, the first detection of PFAS was in a water supply well in Hyannis, and it was about 100 nanograms per liter. And that's when Silent Spring Institute did this work. There was no government didn't do it, but it was an academic research project by Silent Spring looking for causes of breast cancer in women on Cape Cod, and they found this in 2010, but we still didn't know what to do. And it's like, okay, well, the limit here back in those days was 200. All right, well, it was a half, so that's okay. We'll scratch our heads on that. No labs were doing it at that time. So we jumped forward into 2013 or so when the EPA did a lot of tests, and they lowered, when they found it ubiquitously in a lot of different wells, they lowered the limit to 70 nanograms per liter. And we're talking parts per trillion. When you're looking at nitrogen and you're looking at parts per million, 10 parts per million is the limit. Well, then you got to go to parts per million, parts per billion, parts per trillion for this. And in 2016, because they were finding it in water supplies, they lowered it to 20. And then just recently, EPA's come up with a new rule, and I'm not sure how the new administration is going to deal with this. It's at 4 nanograms per liter. Massachusetts limit still presently is 20 nanograms per liter for 6 of the major compounds. That is either one of them or all of them could be summed up. So I want to get back to the Fire Training Academy. And here's the Fire Training Academy here. This is an outline of the pond. These were the wells here, 1, 2, and 3. And so we're seeing a concentration here of about 2,000 nanograms per liter coming off this plume. And that's just when I did this in 2017. You could think that this was at some point had to already travel, because it only takes 3 years from here to get there. So this plume is,
once again,
3 years. The groundwater flow from this point to that point takes 3 years. And when we do contaminant assessment, sometimes it's just a snapshot, and particularly here. So these things could be episodic, so that you can have a slug move through, and maybe there won't be any, and then maybe another slug move through. So what we're looking at here is a slug. This had already been here. These wells were seeing over like 400 nanogram per liter in that. I'm gonna take one more question because I gotta get some time, and then we'll have questions at the end. Yes?
What distance is that?
That's about 1,500 feet. 1,500 feet to 1,700. So it's not very long, right? So groundwater moves a foot per day, something like that. Figure that out. It's 300 some odd feet. So it's like it takes about about 3 years. 3 years for that to get here. And then we have the airport. And the airport has had these areas that they also trained with, and then they had a storage area over here for the fire trucks and that, and so their plumes of contamination came down, and these are the Mar wells here. Okay, so we got the Mar wells here, we got these plumes coming into the Mar wells, we have the fire training academy that you can still see up here, and here's some of the wells that I put in here to measure this. So we've got these two major plumes. So I've been working with this group, it's a Hyannis PFAS community working group, because we have these two major sites here in Hyannis, the Fire Training Academy and the airport. We had contaminated water supply. It was in the top 1% level of contamination in the nation for drinking water. That's started the study that I'm doing with Silent Spring. But this infographic, again, here's the rotary here, and so we've got these wells, and we've got the Fire Training Academy plume coming down, and we've got the airport plume coming down. So this stuff was being used since the 60s. I'm saying we'll start it at the 70s, conservative. So it's been in the water supply, right? I mean, it just makes sense that it only takes 3 years, and they started using it in 1970. It's in the water supply. And they weren't like holding back when they were using it. You saw in the film. So what happened is these wells get contaminated, and nobody knows about PFAS until 2013. So what happened to all that PFAS contaminated water was it gets pumps into the distribution system, and so a lot of people live in Hyannis, and so this is the area of Hyannis. So this contaminated PFAS water is being served to this population. This area here is septic systems. So the contaminated water that goes to this area goes through the septic systems. It doesn't, the septic systems don't take it out. Wastewater treatment plant doesn't take this stuff out. So it goes through and it gets into the aquifer. And then there's also those areas of Hyannis that are connected to the treatment plant goes into the treatment plant here, and that goes into the groundwater. So now we've got these primary areas of contamination, and we've got these secondary areas of contamination that have been impacted. So these wells also have been impacted, and these ponds also. So the Hyannis PFAS Community Working Group is working to try to bring this knowledge and bring better cleanup and better understanding to this situation. So how were the wells? I did the sampling. This is the big news that you have to walk away from. Is all the PFAS in Hyannis now is treated to non-detect. So it's 11 water supply wells. We're going to hear a lot from Chatham about his work on this as well. So at a capital cost, I think they're up to about $50 million, and with O&M costs of about hundreds of thousands of dollars per year to change out these carbon filters. When I mentioned the PFAS limit was 20 in Massachusetts, these are some of the levels that still exist in those wells prior to treatment. So you see they're pretty high all the way down through here. Good thing is it's treated now. And the town is happy that they're treated, and we don't really hear a lot about PFAS in the town.
What happens to the carbon then?
The carbon gets changed out. So the carbon is tested.
Where is the bad carbon then?
Is a lot of sometimes it's regenerated, incinerated with under pyrolysis. Thank you, sir. And and so you need temperatures over 100, about 1,000 degrees to get rid of PFAS when you burn it. And that's a whole nother story. My friend Greg could tell you about it. The MMR, they had one of these training areas, and they cleaned up all the oil, and they put it through a furnace, and they got rid of all the oil, and they put the soil back and all that. But it didn't take the PFAS out. So this site, even though they cleaned up all the oil out of the soil, they still had PFAS. So part of this work that I'm doing with Silent Spring for a look back is it's also combined with blood serum analysis that they did on a number of people in the town in Hyannis. So they had to go out and talk to people and get them to say, yeah, we'll join your study, and you can have the blood. And so this graph shows these compounds. Here's several of the compounds, the PFAS compounds. This is these are some of the most famous ones. And this is I got 3 graphs per compound for Hyannis. This is the national mean for PFOS in blood. This is Hyannis. It's about 10% higher. There was another town in the study that was higher. This compound here, the median concentration in blood from people in Hyannis is about over 3 times the national average for this PFHXS compound, perfluorohexane sulfonate. So the people in Hyannis are still kind of walking around with this PFAS in their blood at higher levels than the national median. So kind of the walking wounded there. So what happens? What about this PFAS? And these are some of the issues that have been associated with PFAS, and one of the reasons why EPA lowered the drinking water limit to 4 nanograms per liter. And so there's quite a few issues that are involved. High blood pressure, developmental effects in children, cancers, reduced immune system, interference with the body and the whole hormones, even increased levels of cholesterol and obesity. And when you go to the doctor over there in Hyannis, and you may have an ailment or something like that, it's like they know nothing about this. So you have to be informed. And so I inform my doctor. I say, hey, we live in an impacted community. We have all this. We're carrying this PFAS in us. Look at these health effects. I want a blood test. So you can ask the doctor for a blood test for PFAS, and my insurance did pay for it. And so I'm above the median. So that's kind of this bit of the story there in Hyannis and what's going on. And so the states and the feds and all that have been really good about supplying money for the infrastructure to treat the water and all that, but yet we still have kind of the walking wounded around here in Hyannis. And what do you do with how do you come about, how do you address that? The last thing I want to talk about is a little bit about the ponds. And so this is a graph showing a PFAS plume coming down into John's Pond, and it goes up into John's Pond and out. And the similar effects happen here in Hyannis. These are ponds in that secondary area that I talked about. So they weren't directly hit by the plumes. So the plumes are coming down over in this area here. And these concentrations are really high, like 6,000 or whatever. But these concentrations are also high. We're talking about 100 to 300 nanograms per liter in these ponds. And we did tests on a lot of the other ponds in Barnstable, and almost every pond had a hit. Probably due to septic systems and household products and things like that. But these were definitely hit by a major source, the AFFF source. And so about ponds is, the DPH, the Department of Public Health, has some limits, but only about 4 or 5 ponds are listed with a public health advisory. And I think their limit for that is 23 nanograms per liter. I was reading about it. And there's these ponds here, John's Pond, had PFAS is up in, the tens of, well, below 100, but, in the tens. And this group pond over here, they did fish studies. And so they found this in fish also. So, if you have a fish limit for PFAS, you limit your fish consumption to 1 meal per week. Pregnant women, children under 12 don't eat any fish from these ponds that have these really high PFAS levels. So just to wrap it up, we're working with the PFAS Community Working Group. We're working with the 2 entities, the airport, the county, and we're trying to push the better understanding. And this is one of the things that we're looking at. And, this is a graph of a performance of a cap at the airport. They put this cap in here, and they said if we put the cap on, all these levels are going to drop, and it's going to help clean it up. This is the nanograms here. This is time from 2007 to 24, and so it dropped. It dropped after the cap was put in, but afterwards it's just kind of been going up and up and up. And that's not the worst of it, is that, well, it didn't show through here, but the limit is 20. Remember, the limit is 20? So these levels are really high, and that's one of the things the community group is working with to get more attention about, hey, this cap isn't working, this PFAS is still getting in the ground, it's still migrating to the water supply. And I just put out a broad list of things, in my mind, and hydrogeology moving forward. These are a lot of the things that I think need attention, or that people are working on. And I won't read them all, but I always put this as like the regional water resource group that I worked with has kind of disappeared, and I feel real bad about that at the county level. And I think the towns and citizens and all that could use a real good, powerful scientific body that serves all the Cape. Presently, I think it's just transitioned to that's gone down. More lawyers have come in, and towns have hired a lot of consultants to do a lot of the work. So it's all different. Everything's in motion. So here we go. America runs on Duncan. Cape Cod runs on water. That's my talk. Thank you.
Thank you, Tom. Do we have any questions? I think we have some questions.
You mentioned that nobody knew about PFAS. But I did see a presentation recently at the Brewster Ladies Library, and the fact of the matter is that 3M and DuPont, they're chemists who made these PFAS back in the 1940s when Teflon was first being introduced to housewives as a perfect thing to put on your houseware. They knew about the PFAS, they knew about the effects, they did experiments on mice and the deformities and things that happen, but affecting women, which, as we know, our health concerns are secondary to these industries. So are these corporations still making PFAS and pumping them into our environment? Are they still being made?
Yeah, no, they as a matter of fact, 3M was the big maker of PFOS, and Triple F. They stopped making it, I think, in 2009, or it was.
So PFAS are no longer being made?
No, PFAS are being made, but they're different types right now.
Oh, different types.
Yeah. but so 3M knew and had this background knowledge, but we on the Cape didn't have a clue, and most people didn't have a clue about it. Yes.
This might not be information that's, available to any of us, but there may be associations between these chemicals and what they saw in little tiny animals, mice and rats. But as far as humans are concerned, you have that list of all of the things that might be associated with these chemicals. What sort of either associations or proof is there that any of these chemicals actually do cause any of those medical problems? My understanding is that there really isn't information about cause and effect.
No, I think there's plenty of that, and then when we're talking, looking at a variety of different things. I don't know if you've ever seen that movie Dark Waters, where they had severe deformities in agricultural cattle and that were in a nearby area that received discharge PFAS. Also, the people working in the industries where PFAS was available got very sick and ill also. So there's definitely proof on this stuff, and we wouldn't have these limits, dropping, and the firefighters as well are right on board with this. They were really, when you think of the phone booth that we saw, exposed, directly to all these compounds, and people I worked with at the fire training academy cleaning it up. I mean, people unfortunately expired very shortly after their retirement.
So, is it specifically the PFAS, or there's plenty of other chemicals in those things, especially those associations with the cattle and the water contamination? Those waters are contaminated with a lot of different things.
Not as much as the PFAS. The PFAS was extraordinarily high, as well as the concentrations in the Hyannis water supply were extraordinarily high.
Well, if you have resources that we could learn more about this and could share with us, I would be really interested, because what I read in the medical literature is that there's no definitive cause and effect. Not that I question the value of this information. I'm impressed that we know so much. I didn't realize that we knew. So thank you very much.
You're welcome.
Maybe a couple more questions?
I have one question. The secondary contamination that you were talking about from water distribution being used in homes into septic systems causing secondary plumes, how much is also being added to septic systems from uses in homes more broadly? Yeah,
well, that's a good question. I think the Silent Spring Institute's had done a lot of work looking at PFAS and septic systems, as well as the Septic System Test Center and that. And even from the work that I've done around the town, looking at the ponds and that. So there's PFAS that does get into the groundwater from household use, normal household use, and you can see impacts somewhere in the order between 0 and 20 would be the highest level. But you can see that in areas down gradient of septic systems, and they also did a study looking at the housing density and PFAS in ponds. And so the ponds that had really low housing density, you really didn't see that much, or if at all. But in ponds that were down gradient, high density areas, you saw PFAS in it, and there was no other source.
And sort of just a related question, with towns that have made these huge investments in sewers and sewer treatment plants, PFAS can't be removed in those plants, is that right?
Not that I've seen yet, yeah.
So the discharges from those facilities are going back into the groundwater as well, correct?
Yeah, that would be true. Yeah. And then the people aren't really testing it. DEP is kind of on the fence with testing it. Maybe Bob Tom can tell us more about that. But that's is an issue, and a lot of it also gets a lot of it does get adhered to the sludge. You know, you separate the sludge out and all that. So you may have heard about that. That's a huge issue up in the agricultural areas where the sludge is applied as fertilizer and gets into the grass, gets into the cows, gets into the milk, and that's what happens. Yes, sir.
Can I be allowed to draw a conclusion?
Go ahead.
So I guess the conclusion would be, if we wait for the federal government, or whatever it is now, or the state government to tell us how to treat these problems, we're in deep trouble. So you have to kind of act independently of the regulatory authorities if we want to tackle these problems.
Yeah, no, it's always been that way in my history. You know, the cleanup in the military reservation wouldn't have happened without the community activists pushing for that, or at least to the degree that it happened. You know, wellhead protection areas, you know, the towns going and voting on zoning to restrict what you can do, adopting performance standards, buying open space. That's community involvement. Those are the people that understand what needs to happen and acting as they need to. And it all just depends on the topic.
So don't wait for a wastewater treatment study, because by the time the state tells you to do it, it'll be too late.
Yeah, you know what? That's true. It's
Who do you think funded a lot of this work? Government.
This work was funded through Silent Spring. A lot
Some of it was.
yeah. Silent Spring does get, you know, they're quite worried right now that they get a lot of their money from National Institutes of Health and the CDC, and those are areas that have been decimated. The people, their contact people that they work with, are being let go. If they're not, they're very concerned about what might happen. Silent Spring is very concerned about, you know, their source of funding. You know, that they work through an association with the Chan School of Health up in Harvard, and you know, Harvard's been looked at as well. So yeah, we're pulling the rug out from under some of the smartest people that we're going to need.
Let's just have a couple more questions.
Could I just ask one question? Because of the lens system on the Cape, and because of this and a number of other contaminants that enter that lens system, is there any studies in terms of what the population density of the Cape is at a maximum in terms of what you could permit in terms of the danger once you exceed that number of individuals?
Yeah, you know, everybody's chasing that number. Everybody's chasing that number. We don't have it, and you know, they look at build-out analysis. A lot of the towns are doing build-out analysis, and how does that affect? And do they have enough water? Do they have enough wastewater? There's just so many different components of it that, you know, everybody's chasing that number, and you know, we don't have it. You know, for every different issue that you might bring up, well, there might be a technological or an engineering solution that moves the line.
There's a gentleman over there.
Yes, sir.
You've talked about the Hyannis case. Closer to us here, as people may know, Chatham has detected PFAS in some of its wells close to the airport there. Are you familiar at all with that case?
Well, I think that's a great segue to our next talk. Thank you.